Doctori, tutto a posto? Welcome back to a new episode of Sane C Libraries. That is a set of C++ platform abstraction libraries for macOS, Windows, and Linux that focuses on fast compile times, being bloat-free, simple and readable, easy to integrate with no use of the C++ standard library and no third-party dependencies. Okay, I've been able to say it entirely. And you can get in touch on Discord, Twitter, or Mastodon, or on GitHub, of course, on the discussions. And so let's go straight into maybe some of the updates. Lately, I've been doing some nice stuff with the iOS porting, which is even the hot reload stuff that was being developed is now be able to be run on an iPad. Of course, you need a jailbroken iPad to do that, but nevertheless, this is working. And I've been doing a bunch of improvements on, the serialization stuff with the addition of some function to read and write the serialized data together with the schema that defines basically the data format for versioning. I have been adding support for the Boolean primitive type. I've been adding support for plugin to capture compiler and link output. And this is pretty nice, actually. Let me show it to you. So now I have, let's say, this refactored SC example where now the registry is basically pointing at a set of examples. And I can modify each one of them. So let's try to modify one. Let's say example one. So example one is this one. And let's add something. Now, let's say I have an error like this. You will see that it fails to compile. Of course, I can fix it. And this is back as normal. So this is pretty handy. I think it should be even showing it here. Yes, even if you hover here. So this is going to be useful to figure out if there is something that doesn't work as expected. That being said, I would like now to create a serialization example. So how can we create something like that? I suspect that the first step will be naming one of the examples to be serialization example. And maybe also renaming the CPP file, which I can do just by copy and paste. Let's delete all of this temporary data. And this example one can be serialization example. Do you like it? Serialization, maybe let's just call it serialization example. Maybe I should write some description. But yeah, for now, this will be okay. I need to regenerate the project. So generate project. Xcode now has the regenerated project. Run it. If we run it, we have the serialization project. Yeah, which is exactly the same as the old example project. So what I would like to do is to create a contract between the host application and this is a serialization example, and the contract is exactly here, this ISC example interface if you want. I don't know if to call it an interface. Does not use any abstract virtual functions because I do prefer to use the regular function object. Can I spell function? Why? Because, probably personal preference, I like to keep the entire Sane C library virtual, free, completely virtual free. There is no use of virtual keyword, which is cause of many problems, in my opinion. In many C++ code bases, it's not like there are some cases in which it can be used. Probably this is one of them, but nevertheless, I can use function and it will be just fine. Even if here, a virtual table will be shared between all of the instances of the object, while here I have a duplicated function for, each instance of this SC example, but this is basically a singleton class, so it doesn't really matter. So let's say vector, so I want to create a function. What signature should it have? I want to create like a serialize function and a deserialize function. This should have definitely a result, which I think we should be adding here, result, and it should be getting a vector uint 8. Yeah, why not? Yes, these are my functions. So the contract will be exactly this one. So I'm going to do as the result serialize, let's see, vector uint 8, I don't know, serialize model state, return true, result true. And unused parameter, of course, yeah, let's say void, and let's make a deserialize. You know what, in the deserialize I could probably use a span. Yeah, let's use a span of const uint 8. Yeah, that's better, because we just need to read, so there is no point in passing the entire vector. Serialize mod state. Yeah, we are not in the SC namespace here, so I'm going to map both of them to the method. So serialize and deserialize. Why does the autocomplete sometimes is terrible here, but we can survive with that. So does it compile? Okay, yes. Now that I have serialize and deserialize, I would like to say that the hot reload system, I would like to basically save and restore the state of the plugin. So I want the plugin to serialize its state and recover that after a hot reload event. I think I can hook myself into the load method here. So maybe we should, yeah, let's do something like that. Result true, and we sc try this. And I'd like now to get access to the IC example. So IC example, I need a query interface to do so I need a library. Let's copy this code. So I'm already in the system, so I would like to get the plugin dynamic library. How can I get the library? I need to check if there is already a library. So I can get the identifier, no, let's say get, no, I need a find plugin, identifier. Okay, got it. Once we have the library, which of course is a pointer because it may be node PTR. So if library exists, so the library is already loaded, and we can query interface, of course, not the driving interface, let's just say example. We can serialize something, let's say vector uint 80, serialized model state, and I can still try this. That's cool. Now, after after loading the plugin, I can redo that. I think I also have to say, yeah, let's also check if the serialize is valid. And here we check if the deserialize is valid. Deserialize. And deserialize, we say serialize model state span to span const. No matching function to call. Why doesn't this is not compiling? Oh, because we don't want to have this, and we don't want to have this. Okay, this is looking good. So now what I would like to create is some sort of model. So model is just something that holds the logic of the application. And I can say serialization example model, which can have serialization example model state. You know what? Let me declare all of the functions in the SC namespace, so I don't have to type SC all the time. I know it's bad because here in theory I'm not a library writer, but I'm a user. So, but if you would like to put things in the SC namespace, that's fine. Or you can do using as namespace SC, of course, which I don't like, so I'm not going to do that. Serialization example model state. So this can be model state. Yeah. So here I would like to collect all of the state of the application. And let's also maybe separate the view. So parallel to the model, we have the view. That's just like a view model type of abstraction. And I'm going to create a view state and a view. Of course, the view state will have its own state. Sorry, the view will have its own view state. And we can draw things here. And the serialization example can have a view and a model. Right, this is so far pretty standard. It's just a view model application. And maybe in the throw, I need to say view.throw. Let's see if this is even working. Serialization. Okay. Is the hot reload working as well? Yeah. Okay. Now, I need to create something. Let's do the simplest possible thing. Let's say I'm doing, I don't know, imgui input int value. And I probably need to pass the model down here so that I can access, that I can say int or uint32 if you want, or maybe just an int32 value. And I can say model.modelState.value. Let's say, let me save it. There is an error. Where is the error? Can I read the entire error? Model was not specified, of course. Model. That's beautiful. Hot reloading is just beautiful. Now, if you see when I'm changing the value, if I hot reload, it will get reset to 0 because I'm not doing what I should be doing here, which is serializing the model state. So that's where the serialization library comes in, because I can just call the reflection, actually, sorry, the serialization binary. And with the serialization binary, I can say, actually, it's the reflection. You know, I need a serialization library to, well, let's do it proper. Let's import the reflection library, because that's what we use to, let's say, describe the model state structure. I'm going to use, I'm not going to use SC library types. So let's say just C reflection struct visit. And let me put this, and this will be struct leave. Is it leave? I can't remember. Yes. And struct field. Is it field? I can't remember. Yes. So here we need to list all of the fields of the structure. Why is it that? I mean, can we infer the fields automatically? Under some limitations, this is possible using C++20 or C++14, using aggregates or other mechanisms. But I have been, let's say, preparing something for that into the library. That's in libraries extra. But I strongly recommend to use the explicit form, because this is going to be used anyway when the versioning is needed. So the automatic reflection, you know, works, but it's I don't think it solves any realistic problem. Now, that being said, we are using reflection to describe the data structure. I can use the serialization binary to serialize the model state. So let's say model, let's say result, save to binary, vector, uint8, buffer. So I'm going to use serialization binary, write with schema. That's a new function that I've been adding, which is preventing the schema, which is, if you want, an array of types that is serializable, and that this describes how the data structure is done. So it will tell that this data structure has int32 value at, you know, in the first position, and so on. This is useful because with the schema, you can add and remove fields, and as long as you have a matching integer here, it's going to be converting and assigning the value even when you deserialize data from a you know, a serialized stream that does not match the same data structure that is currently in memory. So this has like a versioning support. So buffer, return, write with schema, no variable. Yeah, this is a boolean, so we can say something like this. I can say load from binary, span const serialized model state. Yeah, let's call it serialized model state. I like it better. Now I can say, let me just try model dot save to binary serialized model state, and load from binary serialized model state. No matching function to call this one. Of course, I need to load, version it with schema, and this is going to work. Now let's see. Changing the value. So now value is 4. Can I change this? And will the value remain? Change me. save. And the value remains. Let's see, can we even hook here with the debugger? Serialize. So I'm hitting save. This is triggering the hot reload. We are in the serialize. So we are serializing and we are deserializing. Serializing. I don't know why this is happening multiple times. I think there is something to fix, but other than that, this is working good. Is it? How many serialization reloads event? Okay. So, what's next? Next now is, yeah, maybe let's also make a serialization to a file. So we can view the file. So I'm going to say string serialized model, let's say, binary serialization path. And binary serialization path, I should initialize it somehow. How can I initialize it? Maybe let's make init method here, where I'm going to use the file system directories. We can initialize it, and then we can say application root directory. Yeah. I need the path library. So I'm going to write into the view state, join into the view state dot binary serialization path. I'm going to write the application directory with, I don't know, state dot binary. Return result true. I need to try this. Is private member. Okay, get application path. And of course, I need to try this. Beautiful. Let's display the string. So this is going to be view state dot binary serialization path bytes including terminator. Boom. Of course, this crashed because this is null, let's say untitled. So I can see it. And I need to initialize this view. Let's say view.init. Okay. Oh, I want one level up of directory, which we can do with the dir name. So I can say, yeah, top level directory is path.dir name of this thing. That's a string view. And I can put it here, top level directory. I need a type. Okay, this is a path as native. Do I like this? Okay, that's where my binary file is. So now I can say load and save to file. Say binary to file. To load from binary file. Oh, I don't know, maybe I should change these names, but for now that they are okay. And this will have a string view file name and a string view file name. What should I do with the file name? In the save binary, I should serialize everything. save to binary buffer. And once I have the buffer, I need to file system that I need the file system library. So file system dot write file name buffer dot as span to span const try. So we are writing the file, and yeah, maybe I can just return true. And when loading, instead, I need to vector uint 8 t buffer. I need the file system read file name vector char or uint8. I think I have been adding recently an overload for that, so that I can load from binary buffer as to span const. Right expected. Okay, so I can load and save from binary file. I'm going to add this into the view, so I can say imgui button save to binary and load from binary. So if save to binary, I'm calling model dot save to binary file with the view state binary serialization path view, and if I'm loading from binary, I'm going to save load from binary file with this file. Maybe I can put them on the same line. Save to binary, load from binary. Save to binary, load from binary. So let's say I'm saving to binary with 4. I'm changing to be 9. Load from binary 4. This is working. Beautiful. So this is kind of like, load and save of the application. Now, that being done, what else can we do? This is starting to be nice. Maybe I can implement saving it to JSON file. Yeah, let's try also the JSON. Let's say save to JSON file, load from JSON file. To save to JSON file, I need to use serialization which of course I need to include serialization text as a JSON writer and reader. So I can say serialization JSON. I can't remember the API, so I need to look for it. There's a write and there is a load version. So let's say write once object, string format output, and options. Format output. So the object is still our model state. And the format output. How do I create a format output? With a vector destination. Buffer, string encoding, and buffer. Does it work? Okay. What am I ignoring? Yeah. Well, I can probably display an error here, but for now that's okay. Just silencing the warning. File name. So once I have the buffer, I can just write. Okay, just write string. Yeah, write string file name. Buffer. I need to build a string view out of the buffer. So yeah, let me create a span. I need to do buffer to span calls slice. I need to slice the last element because it has a trailing 0. Buffer.size -1 and text. And once I have the text, I can say text false, which means no, true. I can make true. It has a null terminator. This is string encoding ASCII. Does it sound good? All right. Instead, loading from JSON file should be, I log it to a string, read file name buffer, and then I can say serialization JSON, read model state buffer as view. Is it like that? I always try to make APIs symmetric. If I didn't do that, I'm bad, but let's see if that's correct. Because the autocomplete is not liking me today. No matching member for reads, so it's probably read string. No member, read string. Let's see what file system has. Read file. Oh, there's a file data encoding. File data string encoding ASCII. Instead, the read, it's called load versioned. Okay. There is a load exact and load versioned on both the binary and the text, so the JSON serialization. The difference is that the load exact in both binary and the text version, so the JSON serialization, requires you to load the exact same data that was serialized on the exact same data structure with no changes in the fields. While the versioned one is also serializing the schema in the case of the binary, and it's doing some more work on the JSON one, such that it will try to match corresponding fields and allow you to add or remove fields and preserve the existing content. So let's add the load and save from JSON file. Save to JSON, load from JSON. Save to JSON file, load from JSON file. Maybe I should use a JSON serialization path, and I can say state.json. And this is a JSON serialization path. Let's put them on the same line. Can we save to JSON, load from JSON? Yeah, buttons are here. Can we try saving to JSON? Let's see, do we have the file? Where is it? Outputs, macOS, state.json. Value is 0. Let's say value is 4 or 5. Save to JSON. Value is 5. And so far, this is working. So it's pretty good. Now I would like to do something more complex. What I would like to do is taking I had an idea. Let's see if this is feasible. I would like to take the imgui example, has a nice canvas view where you can draw things in imgui. And I would like to persist the state of that control using the serialization. So let me try to show it first of all. Where is it? Is it imgui example show demo window? So I'm going to show the demo window. What am I doing? Oh, sorry, wrong capitalization. Examples, simple, no, that's not it. Custom rendering, no, that's not it. Where is it? Is it the simple overlay? No. I can't remember what was the name. Console, no. I'm sure I've seen it. Was it somewhere else? Auto resizing window, manipulating window titles. Oh, maybe it was in the custom rendering. Yeah, it was in the custom rendering. Canvas. Here we are. So let me copy the code for this one, okay? Because I can draw these lines and I would like to persist them. Hopefully we can copy the code from the example of imgui in our own example without this being problematic with our statement of not using external libraries. So let's see, where do I have imgui? It's in the packages cache, dear imgui demo. Let's find this, enable grid. Here we are. That's exactly what we want. Nice and clean. I don't think I want the tab item, so let me copy this code. Where can I copy it? Where is my draw? Void draw canvas, model, and we need f mod f, which I suspect is in math. Okay, now I need to remove the demo window. And where should I call this? I should call this, right? Draw canvas model. And use it parameter model. I don't care. Beautiful. Okay, so yeah, this is, you know, very, you know, so many years of copy pasting code other people wrote. So it's a skill. I know, I'm really good at that. So how can we persist this? First of all, we have this scrolling, which is, I guess, this parameter here, yeah. And then we have the point. So it's pretty simple data structure with this vector of ImVec2, which is a XY, couple of floating point numbers. So let's say I'm putting ImVector points here into our data structure. Let's say 1, and this is points. I maybe want to use initially the SC vector type instead of the, you know, regular vector from imgui, but let's see if we can make it work like that. So if I do that, I'm starting to have a lot of problems, you know, typical C++ craziness, because of course we are not describing the ImVector 2 points. So let's say I'm describing this type using same system you have seen here. We have an X and we have a Y. And this is, you know, few lines of code getting rid of the craziness of C++ errors. So now the reflection systems knows about ImVec 2 structure. Let's try to use it here. So I can say ImVec SC vector ImVec 2 points is model.modelState.points. Of course, there is, yeah, the interface of SC vector is different from the one of imgui, but I think we can make it compatible in a relatively small amount of time. Let's say I'm making this sides. Of course, sides D and int is not compatible, so let's say that type bonds sides. Let's see if this is somehow working. Can I save this to JSON and save this to binary and load from JSON and load from binary? This works, guys. Yeah, load from binary, load from JSON. Let me say JSON. Can I, that's terrible. Remove one, JSON. My drawing skill is really extreme. Can I write a N? That's terrible. That's not a N. I don't know what am I writing. Yes, so save to JSON, load from binary, load from JSON. Yes, this works. So, and does it work even in the hot reload? Let's try changing the color of something. This is, I guess, the color of the lines. Let's make them green. Is it like this? Yes. And they're green. And so you see the serialization is saving the state of the application and restoring it such that you can keep working on your code. And as long as you don't crash stuff, that's going to be instantaneous, because the Sane C++ libraries compiles really fast. And you can section your application in multiple plugins with dependencies so that you only reload what is really necessary. Now let's try to do something more complicated. I would like to use the actual ImVector here, which is not going to be nice, because supporting this kind of things in the reflection system is not going to be easy. To do so, I will need to copy some code, because that's the only way in which I can remember, from here. So I'm going to take the code that is wrapping the SC vector with the reflection system. And you know, this is more complicated to wrap into the reflection system, or let's say describe in the reflection system, compared to this type, because this is a very simple structure. This is a template vector data type, so it's definitely more complex. So this reflex needs to live into, it definitely needs to live into the namespace SC and in the namespace reflection. Let me copy it. Of course, we don't need SC vector, but we need sc ImVector. So let's compile it. This is okay. I don't need this table stuff, which is hopefully something that I'm going to get rid of at some point, like the command was saying. For now, let's just pretend that this does not exist. I also need the supporting code from serialization binary data type. Where is it? Read version. Yeah, I need this one. This is a namespace serialization. You have to be in the correct namespace for things to work. So ImVector. And to copy everything regarding ImVector, sc vector of t. And I'm going to copy also this one and replace sc vector with ImVector. I think I need to do the same for the text serializer because, yeah, you know, that's just going to be the same as sc vector. So I'm copying the exact serializer and I need the version serializer. Where is it? That's it. Okay, redefinition of things that of course needs some ImVector replacement. That's good. This is compiling. So can I now replace this with an ImVector here? Okay, no member data. Of course, this is the interface that we use to access the data, the sides and resides objects in the vector. ImVector has a different interface. It just has a resides method and does not return true or false. It just errors out on memory, you know, if you run out of memory, so we can only return true. Implicit conversion. So we are going to cast it to an integer. What else? Object data does not exist. Does it have begin? Okay. LF value reference. ImVector. Does it work? So now we are using the actual ImVector, right? Load from binary. That's working. Load from JSON, even the JSON one. So you see, we have been wrapping completely custom data type, which is this ImVector, which is a template data type defined into another library. And we have actually been able to load data that was serialized with our own vector data structure. Of course, you can say vectors are vectors no matter how you implement them, but it's cool that, you know, there is a way to map a vector to another completely different vector and have the serialization system work automatically. So what's cool about this system is that, for example, now I can, let's see something about the version and serializer. Now I want to change this value from int32 to, I don't know, a float. So let's say this is now a float and I need to do input and input float. Okay. If I do that, you see that the value of 3 is preserved and is converted to a float. So that's what's cool about the versioned serializer. And even if I do the reverse, and now I'm saying, I don't know, 6 point something, and I put it back to be an integer, oh, maybe I should have been removing, yes. Yeah, the focus was somehow keeping it with the old value, but you see this has been cast to a value of 6. So that's exactly what the versioned serializer is doing, which is this load versioned with schema and write with schema, which we can see what they're doing. The write with schema is taking the schema, which is this context type that describes the data structure you are serializing. You can see it as a signature, if you want, of the type. But it's not just a signature, it's not a hash. It does have detailed information about all of the types. Once you have this type infos, you can just dump them because they are an array of integers at the end of the day. And then you can append whatever is the data that has been generated by the binary serialization system. You do the reverse when loading, so you first load the type info, which is this schema, and then you can load the serialized data, and this allows the system to do this mapping. How is the mapping done? It's done through this field, so it knows that the data that exists at index 1 is the one that goes into the points, which is here. The data at index 0 goes into value. When it checks the current schema with the schema that's stored on the file in this case, and it's able to say, oh, that's a float that I have in my file. Here I have an integer. It's going to convert it in dumbest way possible, but it's going to work somehow. There are even options to prevent these conversions from happening, and you can have your serialization fail if that's what you prefer. So that being said, I think this ends our video, and I'm really happy about what I have been doing. This is pretty cool. Oh, I saved to JSON this one. I lost my I hardly, really hard to throw JSON. Hard. Let me write it again. No, maybe not. And so you can see that you can iterate as long as you don't crash with a hot reload and have the state being persist. Another thing that I can do, and maybe I will do it offline, is to also persist the view state, which means creating, actually we already have the view state here, maybe moving the enable grid boolean and the context menu into this view state and serializing it in the exact same way as we have been serializing the regular state of the application, so that even the view state, which is variables that do not contribute to the state of the document. The model state is what you would be saving into a file if this was an application that says, okay, save my work here. So the content of what goes into save my work, that's the model state. Everything else, the transient state of, I don't know, your zoom level or your panning level, or the options like, oh, enable the grid or enable context menu, this is part of what I always like to abstract as view state, which is the state that it's transient, it's going to reset when you reboot the application, but it's handy to restore it when hot reloading, because for example here I'm now disabling the grid, but if I hot reload, this is going to be re-enabled again, and even my panning will be lost. So it may be helpful to have it saved and persist and restored, but I'm not going to do that because that's a copy and paste of what I have already done for the regular model. So I guess I will clean up a little bit this example and post it so that you can try it, and you can let me know if you think this is useful. You can copy it and maybe change it. So I'm going to say goodbye and see you next time with Sane C++ libraries.